Hello everyone, welcome to week 2 of the problem solving session. I load for around 5 minutes, then I'll let others join, then I'll start the session. Uh, I'll ask some MCQ questions, some numerical questions, and you can go through the questions yourself and solve the questions and then write the answers here. So go to the Q&A, write something ABC or anything, and then post it here, or even for numerical question also. This is the like same process only. Shukriya, do you have any question? I have unmuted you. Can you? Okay, so actually, I think there are not many students today, so I guess I can allow microphone for all right now. So let me see how that goes. Otherwise, later on I'll turn the microphone off if it is problematic. So when I'm asking or presenting some question, you can also unmute yourself and also can like answer the question. Okay. Okay, so let me start. Basically, we'll be solving some MCQ questions and then some numerical, like there will be some sample C program. We'll ask what are the outputs and the reasons for certain outputs. Data, mainly it is related to this week's topic only, mainly C data types and things like that. So let me begin with the first question, which is a MCQ. Which is the correct way to declare a constant in C? So first option is int const a. Second option is constant a int a. Third option is hash define a, and option D is both a and c. So please
C.
to sorry, can you repeat?
Option 6.
C.
Yes.
Okay, C. Any other answer right now? So you're not audible. Okay, many are saying D. D is basically a combination of both int A, option A and option C. Let me check any other. Okay, some people are saying A. Okay, so the actual answer is the option D, because there are two ways to declare a constant. One way is that with hash define, like if you if you set some variable or anything with hash define, then what it will do is that it will search through all the program and it will replace those, like wherever there is a in the program, it will replace the value with the actual value of the a. And another option is that in constant a, which will be handled by compiler. So you can use both the ways to define a constant in C. So the correct answer is A and C. So that means the correct option is like D. So actually it should be like this. So this is the correct option. Okay, so this was, I think, one of the easier ones. And let me go to the next question now. What will be the output of the following code snippet? So we have assumed that we have stdio.h defined, we have int main. Within that, we have a print statement, printf percentage d, 5 equal to 5. Okay, I think all of you should actually answer in the chat box only. Option C, some of them are saying option D. Okay, option D is what? True. Okay. Okay. Any other answer? So basically, what will happen here is that uh, uh, here we have written 5 equal to 5. So this is a comparison, right? So is it true? Yes. So 5 equal to 5 is true. But since we are printing percentage d here, it will print 1. Why? Here in C, like value of true is 1 and value of false is 0. So that is why it will print 1 here. So let me just show you maybe some, just maybe try to execute that only. Uh, I can use some online compiler and just use this only. So here everything is mentioned, std.io.h is there, int main is there. Within that, let me write this one. Yeah. So see, the output is 1 because this is actually a Boolean value, which is true. And if you write it in a like decimal format, then it is value of the true is 1 and value of false is 0. So that is why the output is 1 here. Okay. So let me go to the next question. Okay, so assume that there is a variable named int in C. Then the question is that how many bytes does it occupy in the RAM in the memory? 1 byte, 2 byte, 4 byte, or it can be many, like it can depend upon the compiler. There is no fixed value. So please type your answers in the Q&A box. Okay. Some are writing 2 bytes, some are writing C. Which one is C? 4 bytes. Okay. Many people are writing B, C, 2 bytes, C, 4. Okay. Mm. So actually, okay, I'll come to second question after some time. So the actual answer of the question is actually for int, there is no fixed size. So it depends upon the compiler. Some compiler int is like 2 bytes, some compiler it can have 4 bytes. So it also in older version of the compiler, like in 32-bit systems, 64-bit systems. So there are many different variables here which can affect actual size of the any data type in C. So the answer is it depends upon the compiler. There is no fixed value here. Okay. So let me go to the next question. Okay, let me go to the question 2 one second because some people had difficulties in understanding that. So basically what is happening here is that suppose we are trying to print this one, printf percentage d 5 equal to 5. So at first what we have to do is that what is the value of this? 5 equal to 5 is true, right? So this is a Boolean value which is true. And we want to print what? A number. Percentage d is a number. So in C and in actually most of the programming languages, uh, value of the true is 1 and value of false is 0. So since this is true here and we want a numerical value for that, this will be printed as 1. If it was like 5 equal to 6, then that is false, then it will be like 0. So I hope it is more clear now. Any confusion on this? Okay. So let me go to the next question now. So assume that you have an unsigned integer, okay, and assume that there is a compiler which assigns 2 bytes of storage for an integer. So what is the maximum value I can assign to integer? So what is the maximum value that I can store in a variable which is of integer type? Okay, many are saying option B. So main point to note here is that here we are talking about unsigned. Unsigned means like it can be only positive, right? So no positive or negative sign is required. So here 2 bytes means 16 bit, right? 1 byte is equal to 8 bit. So 2 byte is 16 bit. And if we talk about binary representation, we start with all zero, which is zero, then like all zero last at the end one, which is one, like that. So if we look at the range, we have to the power, like we have 2 bytes, which is 16 bits. And within the 16 bits, we can assign to the power 16 values, unique values. But one of them is zero, right? So the maximum value we can store is to the power 16 minus 11. So for let's say, let's take a simple example. Let's say we have a 2 byte. Okay, sorry, we have a two bits. Okay, so what are the values we can assign? If we can assign 00, 01, 10, 11. So what is the maximum value? 11, which is 3. So the formula should be 2 to the power, this is number of bits, which is 16 minus 1. So this is for unsigned integer. For signed integer, this is different. Okay. So that you need to keep in mind. Any confusion on this? No, C is not the correct answer. Okay. So why it is like why what is the deal with unsigned integer? Unsigned integer means let's say we have 2 byte storage. What I'm saying is that I will only store positive values here. So in signed integer, like if you define int a, int b, what happens is that the first bit is reserved for sign. So let's say there are 16 bits. So first bit will be reserved for positive or negative, like 0 or 1. But uh, if I'm saying that unsigned integer, so all the 16 bits will be reserved for value only. So because I'm saying that I don't need a bit for positive or negative, I am confident that I will only store positive values there. So all 16 bits will be used for like number only. So what are the options? Like 2 to the power 16 possible combinations are there, and the maximum value can be to the power 16 minus 1 because we are starting with 0 or for all the combinations. So next question, what is typecasting in C? There are 4 options: assigning a value to a variable, converting a variable from one type to another, or defining a new data type, or initializing a variable with a constant value. Okay, so mostly option B, and yes, that is the correct option. So we use typecasting when we want to convert a variable. Let's say we have an integer, we want to convert it to a float. So at that time, we use typecasting. So next question, we have a program. So I will run the program, but the idea is that you should be able to write it in a paper or something and calculate the output by yourself without running the program. So we have a int a equal to 5, int b equal to 10. We have some addition, some subtraction operation. Then we are printing a and b. So what will be the output? Please tell that without running the code. So I think you already saw this kind of pattern earlier. So this is a program to kind of swap the two variables without using any extra variable. So basically what will happen is that here, let me show the steps actually. So at first you have a here equal to 5 and b equal to 10. So what will happen is that at the first step, a will become a will become a plus b. So a here is 5 and b here is 10. So a will become 15, right? Then in the next step, b equal to a minus b. So the value of a is now 15 and value of b is 10, right? So 15 minus 10 is 5. Then in the last step, a equal to a minus b. So what is the value of a now? 15 and value of b is 10. Sorry, value of b is 5 here. So 15 minus 5 is 10. So if you print that percentage d a b, so a will be 10 and b will be 5. So option A is the correct option. For any doubts, please write it in the chat only, like Q&A only. Yeah, and this is the question. So this is basically a very popular method to exchange the variables, swap the variables. Initially, the value was equal to 5, b equal to 10. After the operations, the value is like equal to 10, b equal to 5. And the advantage of doing this is that we don't need the third variable, temporary variable, to store any value. So yeah, this is a very popular method for doing that. Okay, so let me move on to the next question. So this is little bit tricky. We have a we have defined the stdio.h. We have included that. Then we have a hash defined function. We have square of x. So basically, what will happen is that whenever there is a square of something written, we'll replace that with x into x. So this is a hash defined macro. Then we have int main, where we are defining the square. We are calling the square. So what exactly will happen? What will be the output? Please take your time. This is little bit tricky. So then please write the answer. Okay, mostly you were saying 25, some are saying 11, option C, which one is option C? Option C is 11, then using macros answer is A option, okay. So it is quite divided actually. Some people are saying 25, some people are saying 11. Okay, I'll give you some more time. I'm expecting some more answers, then I'll solve the question. So one thing is that answer is not 25. So anyone who wrote 25, maybe can you try it again? I'll solve the solution. I'll give you the solution, but can you try it again and see if you can solve it? The answer is not 25. Okay, I'm getting some 13. Okay, 25 because square of 2 plus 3 equal to square of 5 equal to 5 into 5 into 25. But are you sure that that is the exact sequence of operation? At first, I'll actually type the code actually. Then I will discuss. Let me just type the code. As simple as c.i.h has defined. Okay, so any more answers? Let me check again. Then I'll go to the solution. Square of 2 is 4 and square of 3 is 9. Okay, plus 6. Okay, so let me run the code and check the output. So the answer is 11. Why is that? I'll come to that. So what happens when you define a macro here, square x, square of x equal to like x into x. So what will happen is that the compiler will replace the square x, square of 2 plus 3 here. So let me just comment it out. What will replace that to int result equal to So square 2 plus 3 to replace it as a this 2 plus 3. So x here is 2 plus 3, right? Multiplied by x again is 2 plus 3, right? 2 plus 3. So this is basically what macro operation does. It wherever there is a square, it will take that. Whatever inside that, it will take it as a. It will take it as a x. X into x is 2 plus 3 into 2 plus 3. So this is what will the value is. So the thing is that here, note that there is no brackets before 2 plus 3, or there is no bracket before here 2 plus 3. So which operation will take which operation has the higher precedence? This one, square, right? So 2 into 3 will be executed first because this is a multiplication. So 2 into 3 is 6, 6 plus 2 is 8, 8 plus 3 is 11. So that is why the output will be 11. So how to fix that? I'll come to that. If we actually want a square, how to do that? I'll come to that. But is anything unclear from this? Please let me know. Okay, I'll repeat it once. So this session is not part of the assignment, but questions are somewhat similar to the assignments, and most of the questions are from the previous year assignment. So this should help you if you want some clarity regarding your assignment. But yes, the questions are different from this year's assignment. Okay, I'll repeat it once. And we are returning 0 because here, let's see, we have told this is the int. So the int means we have to return something. And here we are returning 0. So basically there are some conventions. In return 0 means, in case of main function, return 0 means that program executed successfully without any errors. But if there are some, like there are different exit codes for different type of errors. So convention wise, we use like for any function, if it is int, we have to return some value. Or for, let's say, for void, in case of void, we don't really have to return anything. So there are many types, but here we are returning 0 to say that like to kind of denote that the program has successfully executed. So I'll come to the explanation again. So so this was the like macro has written square x, and here we have x into x. So basically what I am saying is to the compile is like to the system is that whenever there is a square written, okay, so here whenever there is a square written from now on, assuming everything inside that as a x. So 2 plus 3, we are considering that as a x, right? And I am saying, okay, then rewrite that into x into x. So basically what I'm saying is that int result, that is fine. Square, I am saying replace the square with x into x, square of x into x into x. So here we have to write 2 plus 3 into 2 plus 3. Why is that? Basically what is happening is that 2 plus 3, I am writing this as a x, and again 2 plus 3, again I am writing it as x. So basically I don't like, they don't care. Compiler does not care if we want a square of a number or what. It blindly follows whatever I said. I told whatever number is there, keep whatever number or like multiple numbers are there, just consider that as a whole number, 2 plus 3 as the one number, and multiply that with the same number. So x into x. But see, if I write 5 here, then it will be like 5 into 5 equal to 25. No issue. But here it is like 2 plus 3. So what it will do is that 2 plus 3, this is x multiplied by here, then 2 plus 3 again. So the problem with that is we don't have any like see this is just equation, right? 2 plus 3 into 2, 2 plus 3. But see there is a no brackets, nothing here. So assume that this is gone. Okay. So after executing this macro, this is the variable now. Int result equal to 2 plus 3 into 2 plus 3. So this operation, because multiplications, if you remember BODMAS, so bracket or division multiplication. So multiplication comes first before addition. So this one will take, this will occur first, 3 into 2 equal to 6, plus 2, 8, plus 3, 11. So then the output here will be 11. So this is how, even though we wanted a square, but because we didn't do some kind of precaution, the program is saying it as 11. How to get actual square here? I'll come into that. But I hope it is more clear now, because there are no brackets there. So it is just replacing that. It is considering 2 plus 3 as x only. So after replacing, because there are no brackets anywhere, so multiplication is happening before addition. And because of that, I am getting a different value rather than 25. So I hope it is more clear. Okay, so the question is that how to suppose I want 25. How to do that? Can we do that with macro? The answer is yes. So basically, what we have to do is that simple. Just give uh, this. So if we run it now, the answer is 25. So what changed? Why giving a bracket suddenly giving 25? So earlier what was happening is that there was no bracket, and because of that 3 into 2 was coming before, it was executing before. But after giving bracket around the x, it is like int result. What it will do is that it will open a bracket, it will take 2 plus 3, it will take multiply, then again a new bracket here, within that 2 plus 3. So then even though there is multiplication in between, but remember bracket execution of bracket happens first before multiplication. So then this will be like 5 multiplied by 5, which is 25. So if you have any doubts, please feel free to ask. This was one of the trickier questions. So by macro, I mean this replacing operation only. So what it will do is that the compiler will check wherever there is a square mentioned, and it will replace. So even before compiling, it will replace the square value here. So that that we call macro here. So the final answer is see. Final answer is 11 because in my question there was no brackets within from before x, right? So whatever I told right now, it is I'm giving what will happen if I keep brackets in front of it. In the initial question, there is no x, so the answer is 11. Okay. So these are the steps. Macro is designed to calculate the square of x, but it lacks parentheses, so there is no brackets here. So 2 plus 3 into 2 plus 3, like x into x. This will execute first 3 into 2. So it will be 2 plus 6 plus 3, which is 11. Okay, so let me go to the next question now. What is the purpose of return statement in C? One is to terminate a loop, B to return a program, C to exit a function and return a value, and D to declare a variable. The recorded lectures will be there. I'll upload the lectures like after maybe 2 3 hours of the session ending. Uh, it should be there forever. Like I don't know forever, but at least it should be there till end of the course. So till your exams and everything should be there. So yeah, this is a simple question. The answer is C, to exit a function and return a value. So to end a program is not a correct option. So return zero is to end it ends the program only when it is used inside int main. So suppose here return zero will like terminate the program because it is from the main. But let's say we have another function int sum, let's say a comma b, uh, return a plus b. So in that case, what it will do is that it will just uh, let's say I'm calling the function sum from here, it will just return the value to there. So the question is that it is not specific to main function. I told in general, what does a return statement do? It exits from a function and returns the value. Okay. So let me go to the next question now. So what will happen if you try to store a value which is beyond the range? So let's say you have a 8-bit variable and you want to store a value, let's say uh, which is not in the range of the file. So will it be a compile error? Will it be a runtime error? Or there will be like no error thrown, but like there will be some issues with your numbers. The numbers might be wrong, data loss or wraparound, or that there will be no issues. You will get the correct output. So Leksha, if you have any question, you can ask. I have unmuted you. Yes, so actually, I'll share all the slides also. So basically, what you have to do is that you have to go to the online courses in PTL. It is there. Okay, let me check once. So all, first of all, recordings should also be available. But another thing is that You can log in into your account, then you can go here, problem solving session recording. Then there will be a Google spreadsheet, and I'll be uploading the slides here. So you can check the slides here by clicking here. And another thing, all the like this video recording will also be available here. So after the meeting ends, I'll upload it here in YouTube and then give the link here. Yeah. So basically in this question, what will happen is that if you don't like if you have some value which is beyond, let's say we have a 8-bit integer, then 8-bit is what? 2 to the power 8 is 128, right? No, 2 to the power 8 is 256. So let's say we give a value which is 300. So what will happen? It will it will not fit into that value, but this will not trigger compile time error or runtime error. There will be a data loss. How? I'll come to that. So there can be two different scenarios. So let's say that what is data loss and what is wraparound. So let's say we have a character defined as X, which is a like 8-bit, right? So 8-bit, the range is minus 128 to plus 127, right? So in this case, what will happen if we give 130, which is outside of the range, this will like overflow. Like this will like uh, let's say if you print the value 130, so this will go, so basically this will go in the negative direction. Okay, so because see, in binary representation, first bit is defined as positive or negative. Okay, so if it is signed character, so in that case, it will be like there will be a data loss. But if it is a like unsigned character, then it will like wrap around. Wrap around means like, let's say the range is 256 here, unsigned character X. So there can be like a maximum value is 255. So if you give 260, it will be like from it will like it will be like 256 is the maximum possible values. So 256 minus so actually if you represent 260, let me tell you this in binary, what will be the representation? Let me just search it once. Of 256, sorry, 260. Let me just calculate only. So let me say we have this one 260. So let's say one is 256, 0, 0, 0, 1. This is 4, 8, 32, 64, 132. Yeah. So this is the binary representation of 260, right? So, but what I'm saying is that we have a like a digit, which is we have a 260, whose binary representation is this only. But what I'm saying is that we can store only 8 digits. So 1, 2, 3, 4, 5, 6, 7, 8. So this will be stored. This will be discarded, right? So what is the binary representation of this? This is 4. So only 4 will be there. Okay. And if the case is opposite, for like if there is like unsigned variable, then the after overflowing, the initial character will be like from 0 will become 1. So if the first character, first bit is 1, then it will come to like minus negative 126. Okay, so actually it counts from left only. I don't know, like, can you clarify your question? Okay, I'll come to unsigned as one as well. Let me just. So what is the binary representation of 130? I think 1, 2, 3, 4. Yeah, this is the binary representation of negative 130. This is your this is 2, this is 4, 8, 16, 32, 64, 128. So yeah, 128 plus 2 is 130. So this is the binary representation of 130. But what I'm saying is that here we are allowing only 7 bits, right? So one first bit is for like sign. So one indicates negative sign here. So only these bits are being used for actual storing the value. Okay, and this is negative, which is sign bit. And in like signed values, they are stored in a 2's complement form. So how do you get the number? You have to complement this. Complement means anywhere there is a 1, it will be 0. Anywhere there will be 0, it will be 1. And after all that, you have to add 1. So let's say 1, it will become 0. 0, it will become 1. 0, it will become 1. 1, 1, 1, 0, 1. Is there 8 characters, right? Yeah, there are total 8 characters. Okay. So after that, you have to add 1. So it will become 0, 1, 1, 1, 1, 1, 0. Okay, no. 1, 2, 3, 4, 5, 6, 1, 1, 2, 3. Okay, this one. So what is the value of this? This is 64 plus 32, 96. 96 plus 16 is so it is like 64 plus 32 plus 16 plus 8 plus 4 plus 2. Here it will be nothing. So it is like 32 plus 8 is 40. 40 plus 16 is 56 plus 4, 60. 60 plus 60 is 120. 120 plus 8, 128 plus 2, 130. So here, sorry, there are some calculation. 64 plus 32 plus 8 is 40. 40 plus here we have 80. So 120 and 4 plus 2, which is 6. So 126. 126 is the value. And because there were 1 at the beginning, so this is called it will be negative value. So I think this will be covered in like more in the later lectures of like week 3, 4. This will be covered in more details. Okay, but in this case, it is no. This is 2's complement because I am adding plus 1 at the end. So this is 1's complement. This is plus 1. This is 2's complement. Okay, and because this is like signed value, so first character or first digit is actually first bit is treated as a signed bit. And in case of signed bit, 1 means it is negative number. Okay, so I hope it is clear. The remaining options. Okay. So there are no remaining option actually. Like it will not throw compile time error. It will not throw runtime error. So this will not come at all. And it is not also true that there will be no issue. Like it will run successfully, but your answers will be wrong. Whatever you are expecting, it will be not correct. So I'll try to go through it again. So basically, suppose you have a 260 as a value, and you want to store the number in a character. The character is 8-bit. Okay. So the range is 0 to 255. So how do we store the values? We convert to 60, we have to convert it to binary because everything is stored in a binary only. So if we convert 260 to the binary, this will be the value. 1, there are multiple zeros, 100. So this is the converted value of 260. But see, we have only 8 bits. So we'll start from the rightmost here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So 8-bit, it will store in the memory. The left one, it will get discarded. It will not be stored into the memory because we have only assigned 8-bit only. So we don't have an extra bit to store this value. Okay. So what will happen when we want to print the value? It will say that at this location, this is the value is coming. 0000 It will convert this value to integer because we want integer here. So if you convert this value to the integer, it will be like 4. The integer conversion of this binary value is 4. So the output will be 4. So if this is clear, then I'll explain the data loss part again. Okay, so let me go to the unsigned part again. So in case of unsigned, it is like we have 8 bits to store the value. But in case of signed, what happens is that this is called sign bit. Okay, first one is sign bit, where if it is 0, then that means it is positive. If it is 1, then that means it is negative. So let's say we have 130. So let me first convert it to the binary. So if we convert it to the binary, the value is 1. So let's say, let me just give maybe another example. Let's say character X equal to 60. So what will happen then? Sorry, let me set it as 64. What will happen? It will be like 0, 1, 0, 0, 0, 0. So 1, 2, 4, 8, 16, 32, 64. Okay. So this is the value. So in this case, since this is within the range of, so in case of character, what is the range? Minus 128 to plus 127. So if it is in the range, then it will, the first bit will be 0. Okay. So if it is positive, the first bit will be 0. If it is negative, the first bit will be 1. So there is no issue if it is within the range. But if it is out of the range, then see, like let's say I am giving 127. What will happen? If I give 127 plus 127, that is, it will become 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is fine. This will become this value. The first bit is 0, which is for positive. That is fine. But if we give it any value which is more than 128, what will happen? This value, the first bit will become 1. So for example here, for 130, the first bit become 1. So that means this value, we gave it that this is plus 130, but the system, the OS, the compiler will understand that this value is negative. Because see, it has no way of understanding if it is positive or negative, because it checks everything by the first bit only. But because since the value is too high, the first bit came out to be like 1 here. So the compiler will think that this is a negative value, and they store the negative values in a 2's complement form. So what happens there is that it will first it will assume that this is the negative value, then they will calculate what is the actual value of this. So in 2's complement, what they do is that they take at first they will flip all the digits. So at first it will like 0, all the 0 will become 1, all the 1 will become 0. So here 1 will become 0. Next there are 5 zeros which will become 5 ones. Then there is 1 0 which 1 1 which will become 0. Then there is a 0 which will become 1. So this is 1's complement. Then they will add 1. So this is the value, new value. Then this is the actual decimal value of the this one. So two information from this part, the compiler got to know that this is a negative value, and by applying like 2's complement, it got to know what is the actual integer value of this. So actual integer value, if you add this, it is like 126. So here negative information it got here 126. So if you assign this sign character x equal to plus 130, the compiler will assume that no, this is a negative value, and it will store minus 126 in the like memory, because plus 130 is out of range for character x, because character x like character range is minus 128 to plus 127. So in priority order, addition and subtraction has like the same priority, so both will be together. Okay, let me move on to the next question. So this is the easy one. You have a, two integers, int x equal to 4, y equal to 5. What should we put here so that it will the logic of the program will be correct? So one thing to note here is that we want output as true. So what should be there so that we get true output here? What will be the fill in the blanks? Okay, so P1 is saying option C. Okay, so yeah, that one is the correct option. So when x equal to 4 and y equal to 5, it will execute true. So all of you are correct on this. So we have a question. So this is, you have to, there is no MCQ here. You have to give an answer. You have to give a value. So we have a function called void function. It will take int x. It will execute x equal to x into 2. And in the main function, we are calling the func a. So basically, we are passing function, and here we are passing 5. And then I am asking what is the value of a. So what do you think will be the output here? Okay, so many people are writing answer is 5, some are writing 10. So answer is not 10. Anybody who wrote 10, can you think why not? Why not 10 here? Okay, so let me try to show this in a graphical manner. Okay, so let's assume that we have this. Okay, so and assume that we have a memory here. So what exactly is happening is that let's say I have defined int a equal to 5. So what the compiler or OS will do is that it will assign some variable here, okay, for int a equal to 5. So this is for a, okay. Then when I'm calling function a, then what will happen is that it will initialize another variable called int x. So let's say another location is there, maybe here. Okay, so this is for int x. Then what will happen is that because we are giving uh, we are passing a here. So what does it means is that in case of x here, it will copy the values from a. So suppose there were 5 here. Okay. So in case of x, it will copy 5 here. Okay. Now the next operation is x equal to x into 2. So what is that in x? It is 5 into 2. So we'll cut this, we'll store 10. Okay. But see, we are not printing anything here. Okay. So after coming back here, we are printing a here. So still now, the value of a is 5 only. So it will print 5 because here, whatever changes are made, that was made in a copy of 5, copy of a. This change was not made in the a itself. So the correct answer here will be 5, not 10. Let me just shift the photo. Okay, let me go to the next question now. So answer is 5. Okay, then we have assume that we again have stdio.h defined, we have int main, and within that we have a double d equal to 9.8, and then we are typecasting it to int, and then I'm trying to print the integer value. What will be the output here? Okay, many options, all are saying it is 9. Okay, let me check the answer. Yes, so all of you are correct. So basically, whenever you're converting from double to int, it will remove the trailing part, 0.8, whatever is there after the decimal, and it will give 9 as the answer. Okay. So our next question, given the following C code, we have character C, we are assigning it as A, and then uh, we are typecasting the character to integer, and then we are printing the integer. So what will be the value? We are giving A, but we want integer value for that. What will be the output? Okay, so the question is that we have a character C. I am assigning A, capital A, to that character variable. Then I am typecasting the variable to C, like to integer, and then I am printing the integer. So what will be the output? So the thing is, in C and most of the other programming languages, the characters are stored in ASCII value. So yeah, many of you are correct, actually 65. So it will store, if you write C, instead of storing A, it will store 65 because 65 is the ASCII value of capital A. So there is a table for that. Yeah. So 65 is A, and 66 is B, like that. So there are like corresponding uh, decimal values of the some characters. Same for like there are some like for a small letter, lowercase letter also it starts from 97. So whenever you're storing something, it is storing in like ASCII value, and if you convert to integer, it will print the ASCII value of the character. Okay, so output is 65 because ASCII value of A, capital A, is 65. Okay, so another question. We have a short A. So short A, let's assume that that is we are representing short as a like short kind of variable with 16 bits. So that is 2 bytes. And we have 32,767 as one variable, one as the another variable. Uh, then what will be if we add them? Then what will be the output? So actually, sorry, I already wrote the answer here. So the answer here is that it will be minus 32,768. But why is that? Can anyone mention? So yeah, assuming that this is signed bit. So it is like at first you have the assume that you have like the first bit is reserved for sign, positive or negative. So one thing is that 32,767 is the maximum possible value that you can store in a short variable. So if you are adding 1 to that, you can store it. So what exactly will happen? So this option is correct. 32, 32,767. So this will be represented in binary as like this. 0, which is for positive, and there will be 15 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this will be the binary representation of this one. For short B, the binary representation will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So again, this one is positive, and at the end there is 1 for 1. So whenever you add them, what will happen is that it will go to 1, then there will be like 15 zeros. Like if you add A plus B. So this and this, if you add at the beginning, it will be 1 and rest everything will be 0. But since it becomes 0, it will become like a negative number. Okay. So for negative number, you have to take the 2's complement, which is you have to consider the like you have to again flip the number. Flip the number is again this only 0 and all 1. You have to add 1 to that, so it will is again this only. So after that, if you convert this to again decimal, it is like 2 to the power 2 to the power 16. Sorry, to the power 16. This is to the power 16. So and here, because this is 1, this is negative value. So it will be like minus to the power 16, which is 32768. So I think it should be 0, 1. This should be to the power 15 actually, not 16. Yeah, this is to the power 15 because there is a sign bit. So sign bit is taking 1. So this to the power 15. This last digit is 0. So this is 0. So last one is 15, not 16. Yeah, Shinjai, you are correct. Okay, so we have a function here, float f double o. It takes two integer values, then it divides the value, and then returns the value. So what will be the output? So note that I am printing percentage f here. Okay, 3 followed by multiple zeros, 3, 3 followed by 6 zeros. Okay, so why don't we check this? Let me just copy paste the program here in the compiler. Okay, so output is coming out to be 3.0. There are 6 threads. So one thing to note here is that if you give percentage f, but the default number of zeros, like default number of digits after the decimal will be 6. Okay, so there will be 6 zeros here. One thing. Second thing is that since you're calling like here, uh, you are giving x and y as 7 and 2, but even though the return type is float, but since these both this and this are integer, whenever you are dividing this will also be integer. Okay, so 7 by 2 will be 3.5, but since this is an integer, it will only show 3. It will convert as 3 to float, which will be 3 point multiple, 3.0. Whenever you are printing that, it will come out to be 3 point 6 zeros, which is same. So suppose I want it, let's make one of them to, let's say, float. Let me say, so actual answer for this question is 3.0. Okay, 3.0000000. This is fine. So let me go to some variation of the program. Let's say I am converting only one to float. What will happen now? Error, some are saying 3.500. Okay. Okay, let me run. So answer is 3.5, then 3.5 and then some other digits. So the thing is that whenever uh, when you are passing the integer here to float, it will convert 7 to 7.0. Okay, and whenever there is one number at least, which is a like floating point value, the division will be float. Division will not be an integer. So even though y here is in integer, but still it will be same only. So even if I make it like this, int and float y, yeah. So then also, like even if only one of them are in float, it will convert everything to float, and this will be the operation. But let's say another question. Let's say instead of int here, okay, let me go to the next question only. So we have a C code. I am so you, you may not be aware of the pointers yet, but I'll describe. So basically, let's say you have defined an array, and there are three values within the array: 10, 20, 30. You are initializing the pointer to the array, then you are incrementing the pointer by 1. What will be the value here? I'll come to that if how it works in a bit, but please see if you can solve it if you are aware. So pointer will be covered in more details in next few weeks. But yes, the answer is actually 20. Why exactly it is 20? I'll try to show you through one uh, diagram. So let's say again we have this program here. Okay, let me delete this. Okay, so let's assume that you have an array. So the thing with array is that when you define an array, they store the values in consecutive location. Okay, so let's say uh, you have defined the array here. So it is starting from this. Okay, and what will happen? There it will be like 10. Here it will be like 20. Next one. Here it will be like 30. Okay. Then there is a pointer which is, let's say, another value, another variable, which may be which might be here. Okay, let's say this is the pointer, star pointer. So pointer is a variable, and what does it do is that I'm assigning array here. So basically this will contain the address of this. So this will point to this. Okay, so this step is done. Then what I'm saying is that pointer equal to pointer plus one. So I'm saying that whatever value you have, you go to the next address. So next address is this one uh, here. So it will point to here. This will be one. Okay, so instead of the 10, it will connect to the 20. And whenever you pin the star pointer, when you pin the star pointer, it will check, it will go to the location it is pointing to, which is here, and it will print 20. Okay, so here is the next question. So we have a float. I'm saving 5.0 there, and then I'm trying to find out the Fahrenheit value of the Celsius value. So what will be the answer? I'm getting 41, 37. Is my screen visible? It should not be frozen actually. Okay, mostly people are saying 41, but I also got some 37. So regarding the previous question, someone asked what if it is like uh, instead of plus one, what if it is plus two? So in that case, it will be like 30. What if it is plus three? Then it will be some random value because we have only allocated three values for this. So the answer is not 41 here. Why is that? Can you please come up with an explanation? Those who were also solved, whoever is saying 37 or 39, those also please can you type your explanation in the chat? Like why it is like please justify your answer. Why 37? Why 41? Pujit, one thing you should note that you are saying 9 divided by 5 into 5 equal to 9, but one thing we should note here is that there are brackets before 9 divided by 5. So that will occur first. Hmm. Okay, so answer here, let me just maybe run the program anyway. So the answer is 37, but why is that? So one thing to note here is that here you have floats equal to 5, but note the sequence of operations here. Let me go here on sequence of operation. So what are the operations? At first, the operation is like 9 divided by 5 multiplied by 5.0 plus we have 32. So one thing to note here is that both 9 and 5 both are integers. There is no float within that. So 9 divided by 5 will obviously take place before the multiplication. And because this is integer, this will save it as 1. This will not give 1.8. Okay. So it will be like 1 multiplied by 5.0 plus 32. So now, because this is again multiplication of between one float and another integer, then it will be converted to integer. 5 into 1 is 5 plus 32 is 37. So the output will be 37. And since we want only two digits after the decimal, it will be like 37.00. So please note here that because both of them are integers, the like division will also be integer only. So percentage here, basically I'm saying to print the floating point value. So let's say this is a variable, not variable, like this is a value which gets calculated and then we try to, so this is a similar percentage is similar to the percentage D only, but here because we want two values after the floating point digit, that's why we're writing 2.2f or like two digits after the floating point. Okay, there are, I think, two more questions. So let me go through them. So, okay, so another question that assume that we have a character which is 1 byte and negatives are stored in obviously 2's complement form. So we have a character 125. We are trying to add 10 to them, 10 to the character. Then what will be the output? This is not 135 because see, I am saying that this is a like uh, okay. So here assume that this is like signed. This is not unsigned. Okay, so assume that. So here I'm saying that we are saving the negatives into its complement form. So assume that the first digit is it can be negative. Although yeah, I think a character should not have been used ideally here, but yeah. Now, instead of character, you can assume this as a short for your okay, because characters are generally like uh, positive only. So please assume that this is a short, not character, and I am saying that this is 1 byte only, and it can be both positive and negative. So again, here also let me change a bit. Okay, so what happens is that 125, if you convert, it is like 0 1 1 1 1 1 0 1. And 10, if you convert to binary, it is like 1010. So if you add them, it is like 135. And if you convert that to the binary, it is like 1 followed by 4 zeros followed by 3 ones. So again, you have to take two's complement, which is you have to 0, 4 ones, 3 zeros. Then you have to add plus 1. So it will be like 0, 4 ones, 0, 0. Last digit from 0, it will become 1. So if you convert this to binary, like decimal, then it is like 121. And since the beginning character was 1, this is negative value. So it is like minus 120. So I think this is the last question. Yeah, this is the last question. So I want you to tell me the output of this program. Okay, so 5 times fail, 5 times fail. Okay. Okay, so what will happen is that at first we have defined a integer array. So 1 to the power 5 is there. I am iterating through all the values. So first value is 1. Okay. So whenever you convert 1 to the character, what will be the actual value here? So note that it will not be 1 because see in character, what do we define? We deal with ASCII values. So let me show the ASCII value chart. Okay. So 1, this is not like see ASCII value of 5 is 35. Sorry, 53. Okay. But what I'm saying is that we have a value which is called 1, which is in decimal. We want to convert it to a like to a character. So this is not really one character one. This is a ASCII value. If you convert, then this is not like this is SCH character. Okay, so this will obviously not match with equal to 5. So it will print fail. Next also it will not match. Next also it will not match, and ultimately after 5 iteration, this loop will be over, and then it will just print fail 5 times, and then it will exit. So similarly, let's say instead of 5, I am giving here 6. What will happen? So let's assume that here instead of 5, I have 6 here and I have 6 there. What will happen? Will it come to the 5 equal to 5? Will it be true? Okay. So what should be the value of here? So let's assume, let's forget about all this. Okay. Uh, let's forget about all this. Int a equal to let's say 10. Then I am converting to character only. Character of a equal to 5. Then okay. So I'm trying to this is a a. This is an integer. I'm converting this to a character, and I'm checking if it is equal to 5. So you can search internet if you want ASCII values, but what should be the value of a to to become not fail this? What should be the value of a instead of 10, so that it reaches here, not in the else function. Okay, 65 is not correct answer. Equal to 53. So if you look at the ASCII values, okay, so see there is 5 here, okay, and corresponding value or decimal value for character 5 is 53. So only when if we give 53 here, then only it will execute as yeah. So now it has executed this value, but if we give any other value 54, it will say it has failed. Yeah. So yeah, these are the end of all the questions. So hope you have understood all of these. I heard there are some you don't have to remember all the ASCII values, okay? But you can remember one thing. Uh, so let me tell you something. Please remember the following. So 0, it is starting from 48, okay? So if you want 1, you can say that like plus 1 is 49. If you want 9, so you can say that 48 plus 9 is 57. Sorry. So suppose you remember the ASCII value of 0, then you can also calculate ASCII value of 5 because they are after after those only. Okay. So 0 you should remember. Then you should remember the capital A, which is from 65, and you should remember the small a, which is from 97. So these three are usually sufficient for everything. Yeah. Okay. So I saw some comments that to explain some other questions as well, which you didn't understand, please write the question number again or just write the description which question you didn't understand. I'll go through them once. And others can you can feel free to leave the meeting right now if you have understood all the questions. Okay, question number 18. Okay, so this is basically what happens here is that suppose we are saying that we have a variable and I want, uh, I told that variable is 8-bit. So basically we have 8 digits to represent the variable. But so let me go through this step by step. So let's say 125 is written. So how to represent this in binary? So it is like 0, 1 is 64, okay. Then 32 is 96. Uh, sorry, 32 is 96. And then 16. I think it is written here somewhere. Okay, so I'm just copying the value. So this is the binary representation of 125. Okay. Uh, so this is there. Then assume that I want to add 10 to this value. So what is the value of 10 in so value of 10 is 0000 801010. So this is the binary representation of 10. Okay. So let me do the summation. What will be the summation? At the end, 00 will be 0, 1 will be 1, then 10 will be 1, 01 will be 1, 11 will be 0, then let me just do it. Actually, I have done this somewhere, so let me just take the summation here. So if you do the binary addition, this will be the summation, okay? After addition, so the thing is that initially 125 is this, plus I am adding value of 10, so this is this one. But the thing is that in short, I am saying that I only have 7 digit to for storing the value, and 1 digit, the leftmost digit for storing the sign. So here it is fine. I am saying this is a positive number, and here it is 0. 0 means positive, so this is fine. Similarly for 10, I am saying this is a positive value, and here also we have a 0. That is fine. But after the addition, this is the value. So this value is what? 125 plus 10 is 135. But I am saying that you cannot store all the values here because only 7 digits are for storing the values, but the leftmost digit is for storing the bit, positive or negative. Okay. So what will happen? The compiler got the idea that this is a negative value, right? So at first it will write negative, then it will calculate what exactly that means. This one. So to calculate that, there is a something called 2's complement. So 2's complement, what you have to do is that you have to take you have to flip every digit here for each of the number here. So minus 0, 1, 1, 1, 1, 1, 0, 0. So for every 0, I'm writing 1. For every 1, I'm writing 0. Then I have to add a 1. So this is 1's complement and plus 1 is 2's complement. So after that, what will be the summation? 0, 1, 1, 1, 1, 0, 0, 1. So if you convert this decimal, this like binary value to decimal value, it will be what? This is 1, 1, 2, 4, 6, 8, 16, 32, 64. So 64 here, 64 plus 32 is 96. 96 plus 16 is 102, 112. 112 plus 8 is 120 plus 1 is 121. So we already got the minus sign from this, and the current value is 121. So minus 121 will be the answer. So even though the summation is 135, but because it cannot store more than 7 actual values, so there is a overflow here, and then it goes to the negative direction, and then the actual value is minus 121. Any other questions? Okay, explain the pointer. Okay, let me go to the pointer question. Okay, so there is a diagram here. So assume that you have an array. You are defining an array, and this is basically your memory. Okay, good enough. So basically, let's say you have defined an array, and then what the compiler or OS will do is that it will assign three memories. So I'm saying here is an array with three values. So it will define three memory locations for this array, and each of the memory location will be consecutive. So at first, here it will store 10, there, then it will store 20, then it will store 30, like that. Then it will point the array to here. So whenever I print like array of 0, it will say 10. Whenever I say array of 1, so what it will do is that it will calculate array of 0, then it will calculate the next location, so this one. Okay, so like that. So this one is stored here. Now what does the pointer do? Pointer stores the address. So let's say I'm defining a s pointer. So pointer is a variable. Pointer here, it is a variable which store address. So let's say I have a pointer and it is storing an address. I'm saying that store the address of array. So where is the array right now? Array is at 10, right? So array is starting from 10. So always it will store the if you give array, it will store the first value only. So here it will point to this location. Okay. So if you say, let's say if you say print this, sorry. If you say right now that print this one, let's assume that this is not there. If you say print this one star pointer, what it will do is that it will go, where is the pointer here? Pointer is actually is not a value. It is pointing to this direction here. What is the value there? It is 10. But let's say I'm saying I'm incrementing the pointer, that I'm saying pointer equal to pointer plus 1. So by that, what I mean to say is that earlier you were pointing to this direction, but now go to the next location. So next location is what? Next location is that I was pointing at this, but now the next location is this. So this works because in array, everything is stored consecutively. Okay. So now it is storing here. Let's assume then again, there is another variable, another statement, uh, pointer equal to pointer plus 1. So in that case, it will point, this will cut this thing, this will point again to this. So next time it will print 30. But after that, even after that, if you do that, then this will point to the next direction, next location. But since we haven't stored anything here, it will like give some garbage value. So pointers, don't worry too much if you don't understand it yet, because will be dedicated section for pointers in next week sessions. Okay, so question number 1, it was, I think, very easy question. What is the correct way to declare a constancy? And there are two ways to define that. One is hash define a, and also int const a. Both way you can use. Yeah, by C is define a. So that is also whenever you give a variable a in the program. So let's say, let me just show you the program only. As define a3. So if I write printf, so yeah, and it will replace the a with 3, but it is a way of defining the constant because I cannot override a later on. I cannot assign a new value. So this is the constant. So yeah. Okay, so I'll end the meeting right now. So thank you everyone for joining the meeting. And you can check the uh, live recording or the like slides here. So you have to go here. You have to go to the problem solving session. Click here. It will create. It will open a Google's slides link. You can click here to see the like slides, and you can click a new link here to see the lectures. So okay, so I'll stop the recording now. So thank you very much.